What is seismic activity? Welcome to Building Knowledge 101. In this video, we look at the geological structure of the Earth to understand how and why seismic activity occurs. So looking at the Earth is made of four major layers. There are the crust, mantle, outer core, and inner core. This first layer, the crust, is about 25 miles thick and consists of about 1% of the Earth's mass. This is the area in which we live, and also the area that earthquakes occur in. The crust is not just one uninterrupted layer. It consists of large pieces that interlock with each other like puzzle pieces. In this picture on the right, you can see where two of those plates are coming together and compressing. This map shows the plates and their locations. The hash lines indicates where the plates are meeting and compressing into each other. They're compressing because the plates are in constant motion, and this motion and compression causes tension between the plates. If you overlay this map with the map of the previous slide, you'll notice that the probability for seismic activity lines up well with those hatch lines. Those lines are known as the edges of the plates and are called faults. There are about 50,000 earthquakes large enough to be noticed without the aid of instruments each year. And about 100 of those earthquakes are sufficient size to produce substantial damage if their centers are located in their areas of habitation. Very great earthquakes occur on average about once per year. Over the centuries, they have been responsible for millions of deaths and an incalculable amount of damage to property. An earthquake is caused by a sudden slip on a fault. The tectonic plates are always slowly moving, but they get stuck at the edges due to friction. When the stress on the edges overcome the friction, there is an earthquake that releases energy in waves that travels to the earth crust and causes the shaking feeling. This illustrates the various ways that a plate can slip along the edges. So you have reverse faults, strike slip faulting, and normal faulting. And then on the left, we showed you an image of where oceanic crust meets continental crust. And this is also an area where earthquakes can occur. You can notice they have shallow earthquakes as well as deep focus earthquakes. So FEMA estimates that earthquakes cost about $6.1 billion annually in billion in stock losses, with about 84% of those losses occurring in California. This image just shows you again the hazard map. So again, the coast of California, very high hazard potential, and also some high hazard areas in the Midwest and the Carolinas as well. In California, there are two plates, the Pacific Plate and the North American Plate. The Pacific Plate consists of most of the Pacific Ocean floor and the California coastline, while the North American Plate comprises most of the North American continent and also parts of the Atlantic Ocean. The primary boundary between these two plates is called the San Andreas Fault. This fault is about 650 miles long and extends to depths of at least 10 miles. The Pacific Plate grinds northwest past the North American Plate at a rate of about 2 inches per year. Parts of the San Andreas Fault system is adapted to this movement by a constant creep, resulting in many tiny shocks and a few moderate earth tremors. In other areas where that creep isn't constant, the strain can build up for hundreds of years and producing a great earthquake when it finally releases. And that is what happened in 1906. The San Andreas Fault slipped along a plane of 270 miles long, and along this line, the ground was displaced as much as 6 meters or 20 feet. And this image just kind of shows you the damage that an earthquake can cause. You notice that the front of the building fell off, and there's just an enormous amount of damage shown in this picture.
That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.